Breaking news. At 0326 UTC this morning, automated monitoring systems across 3 continents registered a synchronized anomaly. Data streams from orbiting observatories and ground-based arrays began diverging from predictive models within seconds. At control rooms in California, southern Germany, and the Atacama Desert in northern Chile, scientists watched the same impossible deviation appear on independent screens. Today, the impossible just happened. Moments ago, the interstellar object known as 3I Atlas exhibited a behavior that no existing simulation anticipated. Not an explosion, not fragmentation, but a sudden, measurable change in physical and energetic properties, occurring without any known trigger. An object we believed we understood has just stepped outside the boundaries of our models. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic discoveries unfolding right now, make sure to like, subscribe, and stay with us, because what you're about to hear is not theory, it is observation, and it is unprecedented. The first confirmation came from NASA's Deep Space Network during a routine orbital refinement. Engineers noticed a deviation in predicted signal return time, small, just a few milliseconds, but persistent. Within minutes, ESA's European Space Network confirmed a corresponding discrepancy from stations in Spain and Australia. Almost simultaneously, optical observatories in Chile reported a subtle but undeniable change in surface reflectivity. This was not noise, this was convergence. At the Atacama Large Millimeter Array, operators suspended scheduled galaxy surveys and redirected the full array toward 3I Atlas. In Maryland, mission analysts flagged incoming data with the highest anomaly classification. Emergency coordination calls began in Paris, Darmstadt, and Pasadena before dawn. The James Webb Space Telescope, operating in infrared bands between 0.6 and 5 microns, was quietly retasked within the hour. Hubble followed, providing visible light confirmation. Radio observatories in South Africa and Western Australia joined the effort, searching for correlated electromagnetic behavior. What emerged was unmistakable. For the first time since its discovery, 3I Atlas was no longer behaving like a passive interstellar object. 48 hours before the anomaly, everything appeared routine. Orbital parameters were stable. The object maintained its hyperbolic trajectory, moving at approximately 41 kilometers per second relative to the Sun. Distance from Earth was just over 2.1 astronomical units. Surface temperature models predicted a gradual increase from 140 Kelvin to roughly 210 Kelvin as it continued inward. Spectral analysis showed nothing unusual. Water ice signatures were weak but consistent. Carbon-bearing compounds appeared stable. No jets, no dust coma, no indication of internal activity. Then, 18 hours before detection, the first subtle discrepancy appeared. Tracking stations at Goldstone detected a minor change in acceleration, 0.02 millimeters per second squared, well below alarm thresholds, initially dismissed as calibration drift. But when Madrid and Canberra reported the same deviation, analysts took notice. There was no corresponding mass loss, no visible outgassing. Solar radiation pressure could not account for it. 11 hours later, thermal imaging from Atacama revealed a pattern no one expected. Instead of a smooth temperature gradient, the surface exhibited discrete thermal zones, patches warming and cooling independently, fluctuating by up to 35 Kelvin over short intervals. No known passive material behaves this way in deep space. 6 hours before the event, radio data showed another surprise. 3I Atlas had been tumbling irregularly since its detection, an expected result for an interstellar body. Suddenly, its rotation began to stabilize. Angular velocity decreased by nearly 8%. Axis alignment shifted into a more orderly configuration. Energy conservation calculations showed no corresponding loss. 2 hours before the anomaly, ultraviolet sensors detected a faint emission line at 121.6 nanometers, hydrogen Lyman alpha, appearing intermittently, then stabilizing into a repeating pattern. Pulse interval, 19.4 minutes. At the time, no one knew what it meant. Then came the moment that forced a reevaluation of everything. At 0326 UTC, multiple instruments recorded a simultaneous shift. Optical albedo increased by 12% across a defined region of the object. Infrared emission dropped sharply in that same area. Radar cross-section changed, suggesting a physical restructuring at the surface. 3I Atlas had changed. Not in shape that could be attributed to erosion, not in brightness from outgassing, but in a way that implied internal reconfiguration. Within minutes, emergency calls were placed. Dr. Elena Kovacs at ESA initiated a cross-agency verification protocol. Dr. Michael Tran at Caltech ordered immediate N-body and thermodynamic simulations. At MIT, computational physicists began modeling exotic phase transitions under minimal energy input. None of the models matched the data. As the hours passed, the anomaly deepened. 3 hours after the initial change, radio telescopes detected a low-intensity broadband emission centered near 1.42 gigahertz. Not narrowband, not a message, but modulated with mathematical precision. Pulse spacing followed a clear pattern: 2, 3, 5, 7. Prime numbers.
This was no longer random. It was responding. Gravitational modeling revealed something even more troubling. Small sections of the object appeared to be redistributing mass internally. Local density estimates shifted without any detected loss of material. One region compressed while another expanded, maintaining overall volume. No known natural process could produce such symmetry and control. At Stanford, machine learning classifiers trained on millions of cometary, asteroidal, and interstellar observations returned a null result. There was no analog, no precedent. 2 hypotheses began to dominate closed-door discussions. The first, the mainstream explanation, proposed that 3I Atlas might be composed of an exotic anisotropic material formed under extreme interstellar conditions. Under solar heating, this material could undergo internal phase transitions, producing localized thermal and structural changes without mass loss. Proponents emphasized the vast unknowns of interstellar chemistry. The second hypothesis was far more unsettling. It suggested that the observed behavior was not a reaction, but a process, that the object was actively regulating its internal state, that the patterns we were seeing were controlled. Dr. Samuel Reed of Harvard reportedly remarked during a restricted briefing, "If this were a laboratory experiment, we would describe this as active matter." Then came the escalation. 17 hours after the initial anomaly, a distinct surface feature, previously visible across optical and infrared bands, simply vanished, not detached, not eroded. It disappeared across all sensors simultaneously. No debris, no plume, no energy spike. Within minutes, the remaining structure adjusted. Thermal patterns redistributed. Rotational stability increased. The object appeared optimized. At the same time, subtle effects were detected closer to home. Magnetometers aboard Earth-orbiting satellites recorded a localized fluctuation of 0.3 nanotesla. Minor, harmless, but synchronized precisely with the object's pulse interval. Shortwave radio operators reported brief unexplained interference over the South Pacific. Navigation satellites logged timing discrepancies measured in nanoseconds. Inside mission control rooms, the atmosphere changed. Encrypted communications increased. Data access tightened. Analysts noticed delays in public releases. World governments were briefed, not on conclusions, but on uncertainty.
No one announced panic, but no one dismissed the implications. As days passed, emissions from 3I Atlas stabilized. Pulses continued, faint, precise, unchanging. Surface temperatures equalized. Rotational motion settled into a near-perfect balance. The object was no longer evolving, it was maintaining. I remember staring at the data feed as the realization set in. The equations balanced, the graphs flattened, and yet nothing about them felt reassuring, because for the first time we were not observing a transient anomaly, we were observing a steady state. In the quiet that followed, reflection replaced urgency. For centuries, we believed the universe was governed by blind forces, gravity, thermodynamics, chance. But what if some objects do not merely obey physics, but manage it? Maybe we are not witnessing a malfunction. Maybe we are witnessing capability. As 3I Atlas continues its silent passage through our solar system, instruments remain locked on target. Every pulse is logged, every fluctuation archived, every deviation from expectation scrutinized. The data keeps coming, and one question now dominates every conversation. What happens when it changes again? Subscribe to follow the next update, because the story of 3I Atlas is far from over.